In today's video, we'll be covering the concept of slope and most importantly, graphing linear equations. To do this, there are two equations we can use, ax plus by equals c, which is known as standard form, and y equals mx plus b, which is known as slope-intercept form. Since slope-intercept form is much more intuitive and practical for graphing, we will only be focusing on this method today. As you may have already guessed, there are two elements which are of importance in this equation, m, which represents a slope, and b, which represents the y-intercept. Let's take a look at an example to better understand these two variables. As we can see, this line crosses a y-axis at 2, so our y-intercept, or b value, is 2. To figure out the m value, or slope, we can begin to think of this in a more qualitative sense, as the rise over the run. Meaning that if I pick 2 points along the line, to get from one point to another, I will need to travel a horizontal distance known as the run, and a vertical distance known as the rise. In this case, my rise is 2 and my run is 4, so my slope will be 2 over 4, which simplifies to 1/2. To better understand slope, imagine a landscape with hills and mountains. We can clearly see that the mountains are steeper than the hills, but how would we make that statement quantitatively? Well, if we consider the mountain, in order to determine the steepness of the slope, we would need to choose 2 points, and then determine how great our change in elevation is after traveling our horizontal distance. In this case, our slope is steep since our change in elevation is large after traveling just a short horizontal distance. If we were to travel the same horizontal distance along one of the hillsides, the change in elevation would be much smaller, and therefore the slope would have a smaller value. So when we calculate the slopes of lines, we just compare the change in y to the change in x between 2 points. If we read the graph from left to right, if the line is trending upwards, the slope is positive, meaning that the y value increases as x increases. Conversely, if the line trends downwards, the slope is negative. If the line is perfectly horizontal, the slope is 0, since the y value doesn't change as x increases. And lastly, if a line is perfectly vertical, the slope is undefined, since a change in x is always 0 and dividing by 0 is undefined. Let's take a look at another line with our improved understanding of slope, while again keeping the equation y equals mx plus b in mind. Since the y-intercept is 1, b equals 1. And as for the slope, before doing any calculations, we already know it's negative since the line is trending downwards from left to right. For a calculation of slope, we will focus on determining the change in y over the change in x, which is just a difference between two y values over the difference between two x values. We get those values by choosing 2 points along the line. My first point has coordinates of x1, y1, and my second point has coordinates of x2, y2. After substituting in the actual x and y values of our coordinates, we can plug them into our equation to determine our slope, which turns out to be minus 2 over 1. Meaning that if we increase x by 1, y will decrease by 2. It's important to note that we can choose any 2 points along the line and the slope will not change. To illustrate this, I could choose minus 1, 3 as my first point and 2, minus 3 as my second point. The change in y will now be minus 6 and the change in x will be 3. Even though the values of the changes are not the same as before, the ratio is still the same since minus 6 divided by 3 is still minus 2. Let's switch things up and try graphing an equation given to us in y equals mx plus b format. In the equation y equals 2x minus 1 is the y-intercept, so we can place a point at minus 1. Remember that the slope is a change in y over the change in x. A value of 2 indicates that the change in y over the change in x is 2 over 1. So if I start at the y-intercept, I will move up 2 to reflect a change in y of positive 2. And I will move 1 to the right to reflect a change in x of positive 1. To make a linear line, all we need is 2 points, so once we have our 2 points, we just have to connect them. And since lines extend infinitely by definition, it's very important to draw an arrow at both ends of the line to symbolize this. Let's do a final example to make sure we understand. Since the y-intercept is minus 3, we'll place our first point at y equals minus 3. Since the slope is negative, we can choose to place a negative sign on the numerator or the denominator. It's good practice to remain consistent, so I would recommend putting it on the numerator. In this case, the slope is minus 1 over 2. To reflect the change in y of negative 1, we will move down 1, and since the change in x is positive 2, we will move 2 to the right. Now we just again need to draw a line through a point, add the arrows, and we're done. Understanding linear equations and graphing is one of the first steps to interpreting realistic data, A scientist who is interested in global warming, for instance, would record the temperature over time and could run a linear line through the data. In this case, the slope would be the rate of warming. There are many other applications, including tracking the position of objects over time. In this case, the slope would be the change in distance over the change in time, which is equivalent to velocity. Or a business could also make use of linear equations to interpret their spending trends. And as a final example, which we will cover in more detail in a future video, we can also use linear graphing to solve a complex system of equations. If the tutorial and explanation was of any help to you, let me know so in the comments and consider giving the video a like. I hope you have a great day. See you soon.